In this video, we're going to look at some of the simpler higher order functions that are available in many of the collections in the Scala class hierarchy. I've preloaded this REPL session with a data structure called scores, which is a vector of doubles, where the first half of the double is a character and the second half is an integer. We're going to use that to mean that this is a set of 26 test scores for some test in a classroom. So one of the first obvious things that you might want to do with this is to sort it by score. So just a quick review on tuples. We have this tuple, and since it's a tuple 2, I use this interchangeably. I call this a double. If we have D defined as such, we can refer to the first field that way and the second field that way. So now let's say we have a function lying around called f, which will take one of these doubles and simply just return the score. So I can apply that to the value d that we defined a few steps above and extract the score for that double. So Scala provides a method called sortBy, which will take a function whose input type matches the type of the collection and sort the elements of that collection according to the result of applying the function to each of the elements in that collection. So in this case, we see that we get back in ascending order all of the scores in the original scores data structure. Of course, this would be a little bit verbose, especially if we're not going to reuse this f. So, of course, we can just embed that directly as an argument to the sortBy. Then we don't bother creating a name for it. And when we're using the functional style, this comes up quite a bit. So Scala has a special syntax for this situation, which allows us to not bother with naming or providing even a type annotation for the argument of the function. What we can do is replace the reference to the formal parameter with an underscore. And as long as each of the formal parameters of the function is used once, and we use them in the same order in the body of the function that they were passed in or defined in the formal parameter list, this will work. That takes a little bit of getting used to, but again, if you use the functional style a lot, this is a really handy, shorter syntax. Now, we don't have to do things as simple as field extraction. This could be any arbitrary body of code. For instance, you can multiply the score by 2. And you'll see that it's, in this case, we get exactly the same value back, because sorting by the score versus sorting by the score times 2, of course, isn't going to affect the order. And also note that we aren't modifying the score here. We're simply using the value of the function to do the sorting, but then returning the original elements from the vector. There are a lot of similarly complex methods available on collections, such as this one, which in this case will be only returning the scores that exceed 80 from our original 26, which in this case is 5 of them. There's also a minBy and a maxBy. And a little more interestingly is the groupBy. Now let's say we wanted to take the original 26 scores and group them into ranges of 10. So if we do integer division by 10, that'll return a value from 0 to 9, and we're going to use that as the key in a map from score div 10 to vectors of those named score pairs. So for instance, we could then see which of the scores fell in the 70s this way. There's a simpler version of that called partition, which is going to group the input into two halves, one for which a supplied predicate is true and one for which it is false. So the example, let's say we have some cutoff above which the students pass, below which they fail. Let's say it's 80. Oops, I forgot the underscore. So there we have the first 5 are those that pass, and the remaining 21 are those that failed. Now a slightly more interesting level of complexity is the find function. Let's say we wanted to find the first score among these 26 that exceeds 80. We know there's at least one. So there. Yeah, in fact, that was the very first one in scores. However, let's say we make a constraint that's impossible to satisfy. You'll notice that find is returning the result wrapped in the option monad. Now again, we'll talk about the option monad at a later video. But one useful way of unwrapping, as opposed to the get. Get is available on the option monad, but it's not best practice to use that. Usually we'll want to leave it wrapped until the very last moment. One way of converting an option of an integer to an integer is to supply a default. So let's say that's the default we're going to mean to use no match. So in this case, because there was an element in these scores that exceeds 80, we're simply unpacking it from the sum. However, in this case, the or else part of the expression is returned.